Hey guys, I'm here today to talk about the Argentinian air show L29 Delphin aircraft crash today. Seen a few videos, read a few articles about that one, but nothing so substantive have come out that what was the pilot doing and how this crash happened. So first of all, my condolences to the families and to the aviation world for losing another brethren of ours in an air show. It's a tragic incident and could have been avoided. Let me go quickly into it. I have downloaded a few videos of the previous acrobatic shows done by the same aircraft, not by the same pilot probably. That's what I could find online, because Argentinian language I don't know, Portuguese. So probably there would be a few things on YouTube if you input the keywords in Portuguese, but pardon my linguistic skills, whatever I could find in English. What I want to say is most of the people believe that this was an aileron roll he was trying to perform. I disagree with that one. Let me show you his barrel roll. So if you could see, the aircraft is coming in and he was into a dive first. He gained a certain speed, climbed up, and then he performed the barrel roll. So let me break it down. When you perform a barrel roll, no matter you're on a jet or on a propeller aircraft, the first thing you do is you want to, from certain level, because you never get your power to 100%, you leave something for any reasons. So your power is almost at 80%. It's never full. So what you do is, to gain extra speed, you put the aircraft into a nosedive with pitch down angle of 15 to 20 degrees with a decent rate of descent, which you could control 4,000 to 5,000 feet per minute. So once you are about to reach that speed, suppose it's 130 knots to perform a barrel roll, if you're slower than that one, your aircraft is going to stall. You would never be able to perform this whole barrel thingy. So if you're faster than that one, then while you're coming down, you have to pull a lot of G's and you can enter into G-lock. So that's also, you could faint out. So you try to be around the speed limits, whatever they are. I don't know about L29, but I know about T-37. We were about 130 knots we used to pull, and we used to pull this T-37 A's and B's. So once you are 10% short of your speed, with that rate of descent which you have maintained, you start to pull up. So which gives you exactly the same speed when you are nose up. So before you are getting into the dive, you select a 45-degree point to your one side and 45-degree point to your other side. So suppose you're going to perform in this way. So you start once you are in the dive, okay? So once you're almost at the speed which you need to acquire before performing this maneuver, you start going towards your first 45-degree point. And as you are approaching towards your 45-degree point to your one side, and you are almost close to your required speed, so you start to pull up. Now, your other 45-degree point would be 90 degrees from you now, so you start looking at that. Once your wing touches that, once your one of the wings, again, your references could be different, but I'm talking about T-37. That's how we used to remember visually when do we start our roll on top. So once you're above the horizon, your wing touches the other 45-degree point, which is 90 degrees to you now, exactly parallel to your wings. You start pulling the aircraft up with G's. You get inverted in the initial point where you start your first descent, and at that time you look at your now 45-degree point and you start to roll out on that one. So that makes a perfect you know, barrel roll we call it. And barrel roll is performed by pitching down and pitching up. You can't start it from certain level with 100% power even, period. So that's my first logic, that the pilot, he was not pulling a barrel roll on his final attempt. Now let's see the second maneuver. The second maneuver over here is a perfect loop. The loop is just an inside loop where the canopy stays inside all the time, and that's a whole 360-degree turn loop. Now for loop, again the same thing. Barrel roll and loops, they start at the same speed. If for an airplane, the barrel roll speed is 135 knots, for the loop it would also be 135 knots. There's another maneuver, the next one, which I'm confused, by the way, what he did. Let's talk about that after that video. So barrel roll and loop, they start at the same speed, and the technique is that so now when you start the loop again from certain level with 80% power, you get your aircraft nose down with a reasonable pitch, 15 to 20 degrees, and then with a 5,000 feet per minute rate of descent. So once you go down, you're about to reach your speed. You start pulling the aircraft, and you have a point of reference right in front of you. Right in front of you. It's like at 0 degrees in front of you. Could be any landmark or anything, you know, a mountain top or the landmark. So you pull on to the horizon, keeping that landmark in view. So once you lose the landmark behind the aircraft's nose, because once you're pitching high, you can't see in front, you can't see down. Now you turn your head towards one of the sides. In my case, I was a student pilot sitting on the left side of the cockpit. So I would look towards this side now, because this is mirror image. So I would just keep this and that side, okay? So once I pulling G's, I come up to the horizon, my landmark is missing. I would look towards one side, and my wing, now again T-37s and Mushshaks and K-8s, they had the same point of reference. The wing used to rotate around the horizon. So now your point of reference is your wing, which is rotating around the horizon in a 360-degree way. And once you are inverted, fully inverted, right, now you can see the ground from the back. So what you do is now you choose the point of reference, which you've already chosen at the back as well, and you start to come down, and the point of reference which you've chosen initially should be in front of you, and your loop is complete. So if it's a good loop, the height lost and the height gained should be equal. So you start off straight on level, let's suppose, at 4,000 feet. So the amount of height you lost while you were gaining the speed, and while you were coming up to the horizon, being inverted, coming down, and again rolling out, it should also be at 4,000 feet. Normally, we don't start maneuvering below 4,000 feet. The ceiling for us was 10,000 feet at least for jets. That's where you could start this high efficiency maneuvers. So definitely from a certain level, you cannot start a loop, because it would look very odd. You know, that won't be a loop. A loop is a 360-degree turn in vertical axis. So it wasn't a loop. Now let's see the third maneuver. Now the third maneuver over here is pretty strange for me to watch. I'm watching it on the other screen. He goes up, there's a pole in front. He goes up, and now till here it's like a loop. And then he has a yaw towards his right side, and he rolls out, and that's it. And then he goes back from where he was coming, and now he pulls up. So now there are two kinds of maneuvers who look similar than this one, which I have which I've done in my flying career. The first one, we call it roll over the top. Roll over the top is half a loop and half an aileron roll. So basically I will go sideways. Again, the prerequisites are the same. You have a point selected at your back, you have a point of reference, a landmark at your back, and a landmark in front of you. So you start going towards that landmark in front of you. You pull up, you pull up. So once you are fully inverted, here you get a front pressure on the control column. Now, how much? That your aircraft is upside down, and you actually check it. We call it check. So now it will stop its rotation for going down. It would stay inverted for less than a second. So once you apply the check, now you have to perform an aileron roll, which is rotating your nose right across the horizon in front of you. So that's now half an aileron roll, and you ease up on the horizon and go back. So that's to change your direction while in a dogfight or whatever, you know. So you don't, because to take a turn, it takes really long. So what pilots do, fighter pilots, they just put the aircraft in, they come up on the horizon, check and rotate and go back. So a shortcut to do that. So that's one. It was not that, because the aircraft definitely came down. When it performed a loop, it did had a nose down movement, and then he rolled and yawed and then went straight. So it was not a roll over the top. So you can see it's coming from the same side where it crashed, and it didn't even pitch up, and that's it. Perfect. So how to perform an aileron roll? The aileron roll is a very unbalanced kind of roll because of the adverse yaw. So again, the prerequisites for aileron roll to gain the speed through losing height and gaining speed. Once you're about to the height, you pitch up, you go up around 10 to 15 degrees pitch up. You're above the horizon. And once you're above the horizon, you can still see the horizon under your nose, but a little bit up above the horizon. And you stop the pitch up movement by putting the control column a bit forward abruptly. Aircraft stops going up, but it stays in this position. Now you would give one side bank. Let's say you give this side bank. So once you give this side bank, now the aircraft has the tendency to go towards the this is called the adverse yaw. So if you don't give any rudders, it's gonna be like, you know, not a perfect circle. So the nose is gonna be like this, like a barrel roll, a mini barrel roll. So what you do is you give the same side rudder, and how much rudder you have to give? You have to keep the nose rotating the horizon. You have to make sure that your nose is rotating along the horizon. That much rudder you have to give, and that comes with the practice. We used to practice these things every single day on every mission. So it's all the mental perception. It doesn't. I can't say that you put 10 pounds of pressure on the rudder and it's going to be perfect. No, it all depends on your own handling. Skinny people like me probably would have to exert more pressure on the rudders, and heavy people like my buddies would have to put less amount of pressure to have because of the handling. So it depends on different people, but what you need to do is you need to maintain this nose on the horizon, and it rotates, just cutting the horizon. So you have a dot once your roll is complete, and you have a pencil, and that pencil could draw something on the horizon. A dot is drawn, not a circle is drawn. So if a circle is drawn, your aileron roll failed. So this was not the aileron roll you saw. He didn't have to. That was about the propellers. Yeah. So now let's talk about the jets. On jets, you can totally do that. You don't need to pitch down because aileron roll doesn't need as much speed as the barrel roll, loop over loop or the roll over the top or the Clover 8. It doesn't need that much speed. From a straight and level flight, you could just speed up to 90% of power. You could gain around, let's suppose if for the barrel roll it's 135 knots, then for the aileron roll, you would need 10 knots lesser speed. So 125, normally the cruising speed is 105, 110 knots for the aircrafts I have flown, T-37 and K-8. So now let's go to the crash video. So you can see he's even below 50 feet. He's just a few feet above the ground level. So he cannot perform an aileron roll from this height, despite whatever his speed is. He was at 500 miles per hour. But he cannot perform an aileron roll over there because it's too dangerous. He would have eventually ended up. So he was trying to go up. From a certain level, you cannot perform a barrel roll as well. So he was not trying for a barrel roll. He was either trying to go right or left. And that's what made him confused. He did go up, not performing aileron roll, not performing barrel roll, not performing loop, because I think it was the last fly past. And he was just gonna, come back and land normally, full stop landing. So what had happened, now there could be many theories, but as you can see, he was into this turn, this side turn, and he stayed there for a few milliseconds. And then he turned over. And that made him inverted. And the jets, because of this is an old Soviet era jet engine, and it cannot sustain the inverted flight for this long. And I could see some negative G's as well. So the fuel supply was definitely cut to the engine. Probably. I could be wrong. I could always be wrong. And then once he completed this half loop plus barrel type thingy, and he was confused with the rudders, and as he was recovering back, if he could have recovered that at that point, he could have gone away. If we just put the same controls, he would not have gone nose down. But I think when he was recovering, he was inverted, and instead of the other side rudder into the bank rudder, he gave the opposite rudder, and that effect became opposite to the aircraft, and aircraft flipped and got a nose down. So it was stalled, but it was inverted, fuel supply cut, no thrust, wrong rudder, stalled, and crashed. So these are my 2 cents. Anything, leave in the comments.